Okay, this is the review guide answer sheet for trigonometry. So in the first question it says find a positive and negative coterminal angle for 390 degrees. Well, what that means is if you draw an angle and your angle starts at the x-axis for the initial side, and 390 degrees would be 360 all the way around, and then all the way around the circle once, that's 360, and then to get to 390 you have to go 30 more degrees. So 390 degree angle is right here. Now what it means for a coterminal angle is another way of saying a 390 degree angle so that you can end up right at the same spot again. So the way you get that is just by adding 360 degrees or subtracting 360 degrees to get back to that same angle. So to get a negative, you can do 390 minus 360, and when you subtract, you get 30 degrees. So that's a 30-degree angle. Well, we didn't get to a negative, so we can put that as our answer for a positive coterminal angle. But what you do is you take your 30-degree angle that you just got and you subtract 360 again. So you're going to get negative 330 degrees for your negative coterminal angle. Now this angle here, you could also add 360 to 390 to get a second coterminal, or to get another positive coterminal angle. And actually you can keep going as many times as you want around the circle 360 degrees so that you get what you need, either a negative or a positive. Okay, so for number 2, we have to find the point where the terminal side of a 65-degree angle intersects the unit circle. So let's draw this out. So 65 degrees, it's about right here. So that's a 65-degree angle. And we want to find where the coordinate, the terminal side intersects the unit circle. So if this is our unit circle, we want to know this coordinate right here. So as you know, or should know, the x-coordinate is found by finding the cosine of x, and then the y-coordinate is found by finding the sine, or cosine of theta, I should say, and the sine of theta. Theta is this angle measure, which is 65 degrees. So we simply just write cosine of 65, comma, sine of 65 to get our coordinate. So you need to make sure your calculator is in the correct mode. So on your calculator, you want to go to mode and make sure you are in degree mode right there so that we can get the correct answer. So all you do is substitute in your calculator. So you can see this cosine of 65, and that will give you 0.422. We want to round this to the nearest tenth. Tenth is 1 decimal point. So the cosine of 65 is 0.4. And then we can do sine of 65 to get the y-coordinate, and that is 0.9. Okay, rewrite 300 degrees in radians. Leave your answer in terms of pi. So we're going to do, as you remember, in a unit circle we have pi radians in 180 degrees. So that is going to be pi radians is equal to 180 degrees. So that's our conversion. So what we're going to do is convert 300 degrees. Now you want your degree unit to cancel, so you're going to put the degrees in the denominator because in fractions you can cross cancel. So pi radians will end up being on top. So notice the degrees cancel. So now all we do is multiply across. So we have 300 pi over 180. And then we just want to reduce that fraction. Zeros cancel. So what goes into 30 and 18? 6. 6 goes into 35 times. and 6 goes into 18 3 times. So your answer is 5 pi over 3. And that's radians. Okay? And then I'll do one more on this video. Pi over 6 we want to write in degrees. Well, this is pi over 6 radians. And since we want the radians to cancel, we're going to put the radians in the denominator so we can cross cancel and put the degrees in the numerator. And our conversion is pi radians for 180 degrees. Notice the radian unit cancels, so we can just multiply across. We get 180 pi divided by 6. And we can reduce. 6 goes into 180 30 times, so this will reduce down to 30 over 1, which is just, I'm sorry, the pi cancels. Pi over here cancels, sorry. So it's just 180 divided by 6, which is 30 degrees. So that's 30 degrees.